Thank you very much for the invitation to come here and to present some data on the vaccines. And I'm very happy to be here today because I haven't seen for a very long time real science. Science is always about data, not about models or about claims that we cannot verify or that we cannot reject. So I'm very happy to have seen so many data today. And as I said, I'm a molecular biologist. I did a lot of gene regulatory stuff. I did a lot of genome biology. And today I would like to tell you something about the vaccines and what they possibly mean and I actually called it what we know and what don't we know. There's a lot that we know, of course, but what don't we know is more important, I think. So let's see where we go. Forwards. That's backwards. Okay. There we go. Okay, we need a bit of basic knowledge to understand what DNA, RNA and proteins are, because we also need to understand what the vaccines are based on. So if we look into biology, and this is very, very basic biology, then we see that in fact biology is based on information and information molecules. The genetic information of all our traits is stored in the DNA, and it is an information molecule, and we find it in the nucleus over here. Is this the right one? Yeah, I think so. You cannot see it. Okay, you cannot see that, but you find the DNA in the nucleus of a cell. And when a cell gets triggered or gets activated, it has to induce an adequate response in the form of proteins. There has to be a protein response. And the protein in fact is a tool that does something. We have seen today already a lot of tools. For instance, an immune globulin, like an antibody, is a tool to recognize something. But also, Pierre, he showed this very nice inflammasome. It's a tool. So our genome is full of tools, coded information for tools, and this is what you need in biological processes, the tools. And we have 20,000 genes, which can be translated into proteins, and it can be translated in thousands and thousands and thousands of